everyone. My name is Monica Enoch, and we are going to revise together static equilibrium, specifically solving questions that comes under ladder. So the question reads, consider the situation in figure 3.2, the uniform 600 Newton beam is armed at P. The first question, they are saying state two conditions of static equilibrium. So the first one is that summation of vertical and horizontal forces must be equal to 0. Another thing is that summation of what talk about a pivot or certain point must be equal to 0. So we write summation of vertical and horizontal forces must be equal to 0. That is summation of vertical forces, that is y is equals to 0, and summation of forces in x-axis is equals to 0. Another condition is that summation of torque, summation of torque about a given point must be equal to 0. That is summation of torque about a certain point, that is the pivot, is equals to 0. The second question, they are saying draw the free body diagram of the system. So we are going to get that diagram which they have given us and try to show all the forces acting on it. That is 40 degrees, point P, and from there, the distance is 3/4 over 4. There is the force 800 Newton. So here is where you have to be very careful. They are saying this is the loop, and always the force that is found in a string or a loop is called tension force. So here there is tension force. Now the thing is that whenever you are having an angle given, you have to resolve in x and y component. So resolving this tension in x-axis, where there is an angle always, you put cos. So it is going to be t cos theta. In this case, theta, that is 40, pointing this side. If you resolve it vertically, you are going to have t sine theta. In that case, theta, that is 40 degrees. Apart from that, what you have to bear in mind is that the length from P to where 800 was exerted, we are not too sure. So that is, we are going to consider as it putting L, which is then like that. Now, from there, what you have to bear in mind is that always the weight of the ladder or any uniform always act at the center. Why? Because that is where the center of mass or its weight is concentrated. So that is, I'm going to put the weight force, which is 600 Newton. So apart from that, what you have to bear in mind is that this weight is acting at the center. So for you to obtain the distance from the pivot point, which is P, to where this 100 was being applied, you have to divide by 1 over 2. Why? Because it is half, that is 1 over 2 multiplied by what? Length. 1 times length, you are going to obtain length over 2. So the distance from P vertically to where weight was is L over 2. Now, apart from that, we have this one. Another thing, we have the vertical component, which is Py, also that horizontal component Px. So this is the solution for question B, where they are saying we draw a free body diagram. A free body diagram shows all the forces acting on an object. So from there, we can now proceed. They are saying find the tension in the tie rope. So from there, you have been asked to calculate what? Tension. So where you can find tension is only from the summation of, it's not only, but you are going to focus much on the summation of torque about a certain point. In this case, I'm going to take P as my pivot. So I'm going to start with this force. You know to say tension or torque is calculated by force. This is torque, it's calculated by force, the product of force times what? The perpendicular distance. So what you're going to do is this. You are going to be multiplying the force applied by that object with the perpendicular distance. So summation of torque about a pivot, in that case that is P, is equals to 0. So what am I going to do? I'm going to get this marker and place it here. So where I'm going to place a marker, this is my pivot point. This vertical force and that horizontal force, they are going to cancel. We are not going to include them. Why? Because their distance is 0, such that when we multiply Py times 0, that is 0, Px times 0, that is 0. Also T cos theta times 0, that is 0. So we are going to remain with the 600 force, T sin theta, also 800. So from there, we can now start. So if I put this marker in at my pivot point, and then I look at this force, which is T sin theta, it is acting upward. So if I apply a force upward going this way, this is anti-clockwise. Since it is moving anti-clockwise, I'm going to add a negative. So that is negative T sin theta multiplied by this what? Perpendicular distance. So my perpendicular distance from there to there, the distance from that point to that point is also equal from this point to where it was. Because this is a triangle. The properties of the triangle is that this length from that point to that point is equal from that point to that point, which is 3 over 4L. So 3L over 4. Apart from that, we go to this force, 600. If I place a marker in and then I apply 600 force downward, this marker is going to rotate clockwise. Then I'm going to put a positive, that is positive 600, that is the force, times its perpendicular distance from there to where it was, that is L over 2. L over 2. Apart from that, the last force, which is what? 800. So if I put a marker there on my pivot point and then I apply 800 downward, this one is going to rotate clockwise. So meaning I have to add a positive sign. 800 times L is equals to 0. So that is negative T sine. My theta, we have been given to be what? 40 degrees. That one. So sine 40 times 3 L over 4 plus, so 2 into 6, that is 3. So 300 times L, that is 300 L plus 800 times L, that is 800 L is equals to 0. So if you punch sine 40 times 3 over 4, what are you getting? So what the figure?
0.48.
0.482. So don't forget that L plus 300 plus 800.
1,100.
L is equals to 0. So from there, what you are going to do is to take this negative to the other side, which is going to be 11,100 L is equals to positive T 0.482 L. So what is common, you cancel. So that length and that length will go. I'm going to remain with 1,100 is equals to T 0.482. Divide both sides by 0.482. 0.482. You are going to get your tension to be what?
2282.16.
2282.16. So
2282.16
Newton as your final answer. So these are the required solutions that we are supposed to be on this question. So if you have found this video interesting, please don't forget to subscribe. Also comment. Another thing, to share to your family members, friends, so that they can also start revising. Thank you so much.